This is the third in a series of webcasts on data warehousing with Informix. And this is actually one of the more exciting ones for me. I am going to talk about two things. One is tips for loading your data, and then two, the Informix Data Warehouse feature. And I'm glad to see some familiar faces on the call, and I see there's some new people on the call. This should be very exciting. So I'm Lester Knutsen with Advanced DataTools, and you can find out more about our company and what we do on our website, which is where you found the link to this webcast. And this is what we're going to do today. The first part of this is I'm going to talk about tips and tricks. We've been building data warehouses for about 15 years now, and there are a number of things that we find are just really important to do, and if we don't do them, we end up messing up and have to go back and redo them. So that's the whole first part of this presentation. The second part of this presentation is going to be on the Informix Data Warehouse feature and Studio. And it's an exciting new product out from IBM Informix that I'm really pleased to be able to share with you here and show you how it will fit into this. Typically, this is the way the data warehouse architecture looks. You have your source data coming into your data warehouse server. Within your data warehouse server, you'll have a staging and load database, and you'll also have your data warehouse database. And it's really important to have those two as separate databases and separate environments, even though most of the time I have them on the same server. And then you'll have a web reporting server for your users to query the data. And that's key, because without users querying the data, the whole data warehouse is sort of pointless. The key to a successful data warehouse, as I've said many times in my earlier presentations, is having users who can query and use the data and use it effectively. So you've probably heard the term ETL, which is the extract, transform, load process. Some people like to reverse it and say it's ELT, extract, load, and then transform. I kind of take a different view of it, and I break it down into these steps. The first step is to get the data from a source system. The second step is to check the data and make sure it's valid. And then you want to load it into staging tables. And this is where you can then, it's in a staging table, you could use SQL against it, you can format it, you can optimize the data. Formatting means things like making sure all the dates have a 4-character year. I've got several data warehouses where we get data from different systems. Some of them still use a 2-character year. And in your data warehouse, you want everything to be consistent. Same number of decimal places for dollar fields, things like that. It also means optimizing your data so that it's easier for people to do lookups, adding keys, adding product information, adding dimension descriptive information. This is where that's all done in the transform process. Something else you might do in the transform process is check and add zip codes, geolocate records. If you have a customer file and you want to be able to geocode them, that could be done in the transform area. And then the next step is to load the actual data warehouse. Load the dimensions first, then load the fact table, and then load the summary tables. And the last step in this whole process is to show a status so that users know that the load is done. This is really important. Users have to be comfortable with knowing what state their data is in and what the status is very simple way to do this is to automate emailing out to the user community a very simple message that says the load is done, and this is how many records and how many dollars were loaded. You can also have a web page that gets updated that shows the results of the load. Another key thing in the post-load processing is to trigger any of the canned reports that need to be rerun. Oftentimes you're doing this load at night, and if you can trigger a whole bunch of canned reports, I have sites where we do 400 or 500 reports every night. That way when users come in the morning, they just do 2-3 clicks and they've got their report up and running. They don't have to go query the database. They've got their report right there with the results from the last load. And that can be very important to speeding up and allowing many thousands of users on your data warehouse. Oh, and you want to automate this whole process. This is really the way I like to look at this is you want one script that does all these steps. And it may call different scripts and different functions to do each one of these steps, but it's one automated load process script. And whether you run that as a cron job or through some other scheduler, that's fine. You want one script that does everything from start to finish. So let's take a look at some of these and drill into them. Why do you want to create a staging area? Well, the key here is you want to separate the source systems and the data warehouse. And you want to be able to QA the data before it's loaded. That's probably the most important reason for having a staging area, is you don't want to mix data. You don't want people querying data that's being loaded and maybe not formatted quite right, or maybe not completely loaded. So the staging environment allows you to load the data up, transform it, and then load it into the data warehouse. This also has the benefit of, if you're doing loads during the daytime, is you can actually have users querying the data in the data warehouse while a load is occurring, because all that work is done in the staging area. And then there just needs to be a few minutes where you cut over from the staging area to the data warehouse, and you need a way of telling users that you're doing that. So the extract process, how do you go about getting data? There are a number of ways to do it. Unload, FTPing files is a very common way. I'm seeing a lot of interest in using data capture tools, log scraping tools to get data. And with data capture tools, you can actually get more real-time data and have loads going on, smaller loads going on during the day, and have more real-time data in your data warehouse. You can also use replication. In fact, with Informix as the source system, I think this is a great way to do your loads, is you don't actually read from the production system, but you read from the replicate system. And if you have high availability replication, HDR, you read your data from the HDR secondary system. So you're not interfering with the primary production system while you're loading your data warehouse. One key tip, and this is the first one I want to do, is for every source system you need an audit file. And the audit file needs to basically be a one-line file that gives you the file name, the number of records, the byte size of that file, and some kind of total, whether it's total dollars, total events, total number of hours, so that you have something to balance to. And it's a very simple one-line file that you want to create. If you're FTPing records, always make sure the audit file is the last record you FTP. That way you know the FTP job is finished and don't start loading while an FTP is in progress and get incomplete data. That's the second reason for using the audit file, particularly with FTPs. But without some kind of audit record, and again, it's a very simple one-line record, you don't know that you've loaded your data right. And this is probably one of the keys I've found over the years with systems that work well, that are automated and seamless, is we have a very simple system of creating audit records for each source and being able to check these audit records. So you send the data over using either FTP, Direct Connect, or replication. I'm actually seeing Direct Connect as another more common one. We have a SQL Server production system that we're loading into an Informix Data Warehouse. And they use ODBC on SQL Server to insert directly into the staging tables. And that makes it pretty seamlessly. Once the data is in the staging area, you want to validate that data using the audit record. And there's one thing you want to do is compare the file or the data you got to the previous data to make sure it's not duplicated. One of the most common problems over the years, and this happens 2 or 3 times a year, so it's not forever, but it's something you got to watch out, is particularly on the extract process. If there's any manual intervention, like you have a job scheduler person that has to type in something to send you a file, is they make mistakes. And by comparing the file you just got to a previous file, you can see if it's a duplicate. This happens in a number of warehouses I work with at least once or twice a year, is the job scheduler will send the same file they sent the night before by accident, just because they forgot to change a file date or something like that. Also, this may save you time. If there's no change in the file, you may not need to reload it. A number of dimension tables I get in data warehouses don't change that often. And this saves you quite a bit of time. If they don't change, you don't need to reload it. And so that's a key step in validating this. And this is done outside of the database. Usually I do this in shell scripts using something like the Unix compare function to compare 2 files to see if they're the same. That's a very simple way to do it. And then your staging tables, you want them to have the same schema as the source tables. You want them to have a way so that you can just load data right into them without any transformation here. Because the idea is to get the data as quick as possible into an SQL database, so that then you can start doing the transformation in SQL. Now, I always truncate the table first so that you clear out the last load. If you're doing nightly loads, the first thing I do is truncate the table and then load the data into it. And the best tool for doing the loads is the Informix High Performance Loader. If you have less than 200,000 records, SQL works fine, and if it's delimited such that SQL can load it. You can also use some kind of data movement tool or replication tool or ODBC. And again, once the data is loaded, you need a way to check the record counts and make sure that if the source system sent you 100,000 records, you loaded 100,000 records. If you don't, if the record counts don't match, you need logic in your code to stop and say, whoops, I need to do something because the records don't count. And all of this can be automated fairly easy with both scripts and with the Informix warehouse feature that I'll talk about in a little bit. The last key point is always archive your source files. I've worked with many systems, and some of the mainframes that I've worked with is we may find 6 months later, a year later, that we want more data than we originally got. And if it's in these source files I have archived, I don't need to go back and extract it again. and especially on mainframes where CPU cycles cost dollars, and if data has been archived off the tape, it's really difficult to go back and get it. So having archives of all your source files, and you know, disk space is cheap. You can compress the files, put them off on some disk space that you know, doesn't have to be very fast. It's just a way that you can get to them easily without having to go back to the source system. One of the jokes at one of the projects we worked on was we called ourselves "Reloads Are Us," because the users kept changing their mind about what fields they wanted in the data warehouse. And it was fairly easy for us to accommodate that because we had archives of all the source files. And anytime they made a change, we could go back to those archives and reload without having to go back to the source system to get the data again. So that's a key point too, is keep your source files around for a while. And then you want to start the transformation process. Once the data is in staging tables, you know it's right, the record counts match, you need to go through and look up the dimension keys. And every dimension in your data warehouse is going to have some kind of primary key. And what you want to do is look that up, validate that the dimension data is correct, and then deal with any missing dimension records. And I'm going to talk about this later on in a few slides. But that's a key part of the transformation process, is how you deal with missing dimension records. You also want to format the tables for the data for consistency. Phone numbers should all look the same. Social security numbers, credit card numbers, dates, they should all look the same. And this is a place to do that. I like to have stored procedures that go out there and just format all the records so they look the same. You want to add data that adds value in this process. Geocoding addresses is a good example of that. That can be done here in the staging area. Also, oftentimes you want to merge data, like cost data. Let's say you're doing a sales data warehouse. Well, this is a good point to bring in the product cost data and add it to each record. So it's very easy to calculate on a record-by-record, transaction-by-transaction basis what the cost was versus what the sales were. And that's all part of the transformation process. Now, invalid data. In dimension tables, this is really important, is you want a record in every dimension table that identifies invalid data. So let's say I'm loading a product table, and I get a record in my load file that the product code is not in the dimension table. There are actually two ways I deal with it depending on the situation and the user requirements. One way is to load that record, but give it a product code of invalid. And that identifies it as, here's a product I got, but I don't have a valid product code in my dimension table. The second option is to add the product code that I got to my dimension table, but in the text someplace identify it as invalid. The advantage of that is then that gives me the product code and I don't lose that on the source data. But it also, both methods allow me to identify possible invalid data. What you don't want to do is reject a record because it has an invalid product code or an invalid org code. I once did a warehouse where they told me up front, you know, the warehouse is not going to balance. Our system doesn't balance. Our source system doesn't balance. And I thought, oh boy, this is going to be fun. And what we found out was the reason it didn't balance is they had transactions with an invalid cost code. And they couldn't see them in their source system because their source system only showed transactions with valid product codes. How they got into the source system, nobody knows. But once we loaded them into the data warehouse, we didn't reject the records. We kept them there and marked them as invalid. It was very easy for the users to go out and find what records were invalid and then deal with them. The second part of missing data is nulls. And I'm a big fan of not having nulls in the data warehouse. If you have going back to the product code, a product code that comes along as null, you need a dimension record that says this is null or an unknown, and you assign that to that product code. That gives users an easy way to go back and search and find bad data and fix it. You want that bad data in the data warehouse so users know about it. You don't want to reject it and not fix it. Now, nulls that are in numeric fields, you want to convert those to zeros. Unless there's some, and there may be some far-fetched logic of why you would want nulls, but that could potentially throw off your math in your query tool, because the standard for SQL is that a null added to a number, the result is going to be a null. And so if you have one null in a fact and you add up a whole column, the total is supposed to be null. And that's not what you want in a data warehouse. You want zeros there. So convert any nulls that are in facts to zeros, or if they're in a field that is like a customer name, convert it to spaces. The reason is it's very hard for users to query data that is null in most query tools. You get into some convoluted or and logic when you do that. It's much easier just to put a space there and let users then query for records where the last name has a space, and they'll find all the users that had nulls in the last name. So this is what a typical dimension table would look like, and this is just an abbreviation of it, but I usually have one record where the product code is null and the description is missing product code. And I'll have a second record where the product code is invalid and the description will be invalid product code. And then I'll have my regular product codes. And so this way, in the data warehouse, I can actually do a query and QA my production data. I'm amazed at how often I find people doing that. That a data warehouse is seen as a key way of making sure your production data is right. Another key is to have a load history table. And this is a table that I keep around forever. I've got data warehouses going back 12, 14 years. And I can go back and see every load. Every load is assigned a unique number to identify that load. I can see how long it took to do the load, and I can see how many records were loaded. One thing this does, and you won't see it in the first year or two, but after you've had it around, this gives you a really good history of, are my loads taking longer? Are they going faster? When you move to new hardware or a new version of Informix, go back and check this and make sure that your loads are as fast as they used to be. And this gives you an audit trail. Auditors love this. I've worked with several systems where we've had auditors come in, and they love the fact that we keep a load history and can go back and show every load that happened in that data warehouse. Now, this is just an example of what a load history table might look like. You have a load number, which is a serial field, and gets automatically incremented. You have the load date, a source and a target, a start time and end time, and then some kind of status for that load. This could be a code that you make up, and it could be very simple as OK or error or pending or in progress. And then you have some kind of error records so that you can identify loads with records, with errors, and then you have some kind of record count. And what you do is when you start loading a file, the first thing you do is you go insert into this table, get the load number, the load date, the file, and you add that load number to every record that gets inserted, so that in your dimension tables and in your fact tables, every table will have a field called load number. And that load number ties back to the load history table so you can know exactly when every record was loaded. And you can go back and look at start times and end times. This also becomes really important when you have to do a rollback, and I'll talk about that later in the slide. But let's say a week later you find out that, oh gosh, the load a week ago was really bad. It's very easy with a load number to go back and delete all the records that have that load number and then reload it. Without some kind of load number in every fact table and every dimension table, it makes it very difficult to have to go back and fix problems and loads that you find after the fact, maybe even a month or two after the fact. Once you've got the staging tables all loaded, you have a decision point to make. Do you load the production warehouse? If there have been any errors, and this is going to depend on your situation, what makes you decide to load or not to load. But if you have any errors, it's easier not to load the warehouse and let users keep querying the current data than to load bad data into a warehouse. And so this is a key point in your code. Sometimes it's very simple. If there's any error in loading the staging area, stop right here and jump to the end and send an email message saying bad load. That will make your users a lot more comfortable than having to explain to them over and over again why the data in the data warehouse is bad because the load was bad. The other thing at this decision point you have to do is deal with the issue of users running queries while a load is in progress. Because up to now, you've been in the staging environment, and it hasn't affected users. But now you're actually going to take data from the staging environment and move it to the production data warehouse. In some cases, it's fine to have users running queries while a load is in progress. In some cases, you may want to lock users out for the brief period of when you're loading from the staging area to the production environment. That's a decision you have to make, and that's part of this load decision point. Now, there are two options for loading data into a production data warehouse. There are incremental loads, and then there are complete loads. And I'm going to talk about incremental loads first. Incremental loads are great for transactions, where you have the day's transactions you're trying to load, or if you load more often, you have the last 4 hours of transactions you're trying to load. They're great for fact tables. You don't want to have to reload a fact table from start. If I've got fact tables with billions and billions of rows, and having to reload one of those is impossible. This way you load only new data and you load changes. Now you need a system on your source systems to make sure that you get the changes. I'm working with a site right now that cannot guarantee that they know that a record has not been changed on the source system. And because of that, we actually have to reload the big fact table every night. You've got to be able to have a mechanism on the source system to ensure that only changes are loaded. This is where the log scraping tools, I think, are really interesting that I'm seeing nowadays. IBM has a great one. There are several out there that allow you to capture only changes on the source system by going through their logs. And that's what you then load into a data warehouse. And if you don't have a system like that, I've created change logs in the past where it's a very simple trigger in the source system that just says, hey, this record got changed. Put a note in the change log so that I know that record needs to be loaded in the data warehouse. So incremental loads are really the best, and this is what you want to do, but you need to make sure that you are guaranteeing getting all changes. The worst thing that could happen is a change to happen on a record in production, and you don't get it because a change date was not captured, or it was not seen as a new transaction. Complete loads are good for small dimension tables. In fact, most of the warehouses I work with, we do a complete reload of the dimension tables. They're also good for snapshot fact tables. In fact, they're the only way to do a snapshot fact table. A snapshot fact table is when you don't have transactions, but what you have is a snapshot of a production system at the end of the day. And that's essentially the only thing you can do is a complete load. It's much easier to set up and build a complete load because there's no real logic involved in that. The downside is it takes a lot more time on a very large database. So try and do incremental loads. If that doesn't work, you may have to do complete loads. Good news is Informix has tools, and the server is so fast that even if you have to do a complete load, that shouldn't be a detriment. I've found we've got systems that are quite large that do complete loads just because they can't guarantee capturing the changes, and that works very well. After you have loaded the fact and dimension tables, you need to deal with summary tables. And there are a couple of options here. One is you can completely rebuild a summary table. This is good for very small summary tables. It doesn't work for large summary tables. And if you're in the last presentation on schemas, you remember I talked about having a pyramid of summary tables where you have your fact table with 1 billion records. You might have a summary table with 1 million records, and then a second summary table that summarizes that down to 100,000 records. This works fine for a table with 100,000 records. It's hard to rebuild completely a summary table when it has 1 million records. What I've found works best here is using triggers on the fact table to update a summary table. In fact, way back in the 90s, one of the reasons I went with Informix IDS instead of XPS was triggers were not available in XPS. And I could rebuild my summary tables much faster with triggers on IDS than I could doing a complete reload in XPS. Also, SPL, stored procedures, are a great way to update summary tables that have a lot of logic. And so you could have a very simple trigger on your fact table that anytime a record gets inserted into the fact table, it calls a stored procedure that then goes out and updates the summary table and keeps them in sync. Now, even on summary tables that you do updates on, you need a mechanism to do a complete reload, an automated mechanism. I'll give you one example. We have a customer that has a very large customer table. I think it's got about 15 million records in it. And they do incremental loads every night into that customer table of changes. And then once a month, they do a complete reload of it. That way they're guaranteed that if they miss something in the source system, because we're depending on the logic in the source system to find out changes. If they miss something, though, by being able to do a complete reload, we'll get it at least once a month. So you need to, even if you are doing incremental loads of your summary tables, you need to have a mechanism to completely rebuild them from scratch. And that's probably a good idea to do once a year. Another way to do this is once a year rebuild your summary tables. And then after the load is done, you want to kick off the standard report processing that you have. And this depends on your query tool, what you're using. With Brio, we used to have a very simple process where after the load was done, it updated a event table in the Brio repository, and when that event table got updated, Brio kicked off all the standard reports. We'd have 400 or 500 reports that would run every night. And so those reports would run to refresh the data for users. I worked with other tools. Most query tools have some kind of SDK you can use that allows you to trigger rerun a set of reports or all the reports in the tool. And that refreshes the data for users so that when they come in, all they have to do is click on a report, and that way you can have thousands of users hitting your web server, clicking on reports, and not actually having to query your data warehouse. That's one of the little secrets to how you build a very fast data warehouse, is you pre-generate the reports, they're sitting out there for users, and they're ready to go. The other thing you want to do when the load is complete is email the results to the users. And this is very important. This gives them the warm and fuzzy that, hey, the load was done, and you want to put things in like how many records were loaded, how many dollars were loaded, how long did the load take. The other thing you want to do is have a status page for the warehouse so that users can go in and see the last load. And this can actually be kind of important, is to update the status page as you go through the load process. So not only can users see the results of the last load, if you're in the middle of the load, they can see where you are in that load. And at the very end, if there's success, that tells users they can start using the data. If there's a failure, you need to have a fallback plan and a way of recovering from that. QA is really key in this ETL process, and I can't say this enough. You want to automate the QA throughout this process. You want to have very simple things that check record counts, check dollar amounts. One of the systems I built was a general ledger data warehouse, and we were able to get a report from the mainframe that was a daily trial balance. And so one of the last things we did in the load was we took that report, which was a standard report they ran, and we compared that with what we had loaded into the data warehouse to see if they balanced. And that gave users warm and fuzzy feelings. If you could tell them, hey, this balances to what your general ledger tells you to do. Now, what do you do if you have incorrect data? You want to be very careful here. You don't want to fix it in the Data Mart. You want to fix it in the source system. If a record comes along with an invalid program code, you want to load that record with the invalid program code, but mark it as an invalid program code. Go back to the source system, fix it there, and then the next night, that record should come along as a new transaction and gets loaded into your data warehouse. And it might be a debit and credit transaction where you debit the invalid record and you credit the record. Or it might be an add and delete where you delete the old and add a new one. But you always want to fix things in the source system, not in the data warehouse, because it's important that the data in the data warehouse match your source system. Users have to be able to trust the data to use it. And this is probably the most important point I have in this whole slide. If users don't trust it, they won't use it. So errors, you will get errors. That happens over time. There are bugs in source systems, and they will come through into the data warehouse, and you need to be able to fix them and bring that data into the source system. Now, rollbacks. This is really important. One thing I like to do before I start a load process, and usually on these large data warehouses I do, we do the loads at night. Before we start any loads, we do a backup. That's the time to do your backup of the database server, the production data warehouse, so that if a disaster really struck, you could always roll back to that backup. But that takes time doing a restore from a full backup. And that's where this load number comes in really handy, is if you do need to roll back a load, if you have that load number in every table in the data warehouse, it's very easy to delete the rows where the load number equals whatever the bad row is. And you need to plan for this. You need to have automated scripts that could do this so that it's not let's scramble and figure out how to do this. Part of your building a data warehouse needs to be building a set of scripts to roll back any bad loads. And I like to be able to both do it by load number and by date. Let's say you found out that 3 days ago all the data we got from the mainframe was bad. You want to be able to take all the records on that one date and unload them. And by having load number in a load history table with a date there, you can do that. And this is key. Restoring from a backup can take multiple hours, especially on a terabyte data warehouse. Doing a delete on what you've just loaded is going to be much faster. So, in summary, what I call the 10 keys to a successful ETL process is audit files for every source system so you know what you're getting and how many records you're supposed to get, having a load history table, using the high performance loader for large tables. I didn't say this enough earlier, but Informix has a real jewel there with the high performance loader. It's the fastest thing I've found, and I've benchmarked a number of systems over the years, and the high performance loader has always outwon almost everything I've done. Another key is to deal with nulls and missing data. You don't want to have nulls in your data warehouse. You want to have the data consistently formatted so that dates always look the same. Social security numbers, phone numbers, credit card numbers all look the same. Nothing looks more amateur than in a report having phone numbers formatted different ways. And that's not changing data, that's just formatting data. Emailing the results. This allows you to communicate with your users. And they're in a data warehouse, the users are the customer. They're the people who use this data. The more you communicate with them, the better. And even when you have a failure, you want to email them so they know that there was a failure and you're taking care of it. That's the key. And you want to automate this whole thing. You don't want to have a series of steps that people have to run. You want one script that will run a series of subscripts. And you want to automate the rollback. Have a plan for it and have it automated so it's very easy to do a rollback if you need to. I just noticed I had email results twice. I should correct that in the next set of slides. So before I get into the Informix warehouse feature, I want to talk about tools a bit in general. What do I like to use? And I'm a command line person, and I like using SQL. I like using shell scripts. Perl is really great. Python is really great. Those are command line tools to use. There are all kinds of tools out there on the market that you can also get to automate data warehouses. Couple of comments on tools, though, and they all look good in PowerPoint. But you need to use them before you buy them, because I'm amazed. I worked with a client once. They did a benchmark of 4 tools, and then we actually did the ETL process in scripts. Of the 4 tools and the ETL process, so there are 5 options they had, the ETL process in scripts was twice as fast as any of the other tools. A large part of that, I think, was because we were using the Informix High Performance Loader. But the other interesting thing was, at the end of the benchmark, 2 of the vendors, and vendors came in and did this with their own consultants, they had the wrong results. And they couldn't go back and figure out where the problem was. Because they had this whole scripted automated process, and it was very difficult in their code, in their automated GUI code actually, to tell where the problem was that they ended up with the wrong results. Now they probably could have found that if they had more time and were given more time. But that's the first thing, is in scripts, it allows you to build it in modules. And you can check each module, each little script, along the way to make sure it's right. So scripts allow you to do it faster. They allow you to do it modular, where you can check the results. The third thing is the learning curve. I know a client that bought a tool, and they thought, oh great, we have a tool. The problem turned out to be finding people who knew that tool. You can find more people who know SQL and shell scripts than you can find people who know a particular vendor's data warehouse tool. It's kind of amazing when you look at tools. Even though they're marketed as GUI-based, easy to use, whatnot, they still take training. And if you do get a tool, you need to plan on training for it. So I'm giving you all these downsides for why you should not use a tool. Another one that I think is kind of important and not often seen is the overhead these tools take. I just had an experience with a vendor that's going to remain nameless because it's not IBM, and their data loading tool, and that required a server as big as the data warehouse to run. And so, in fact, in some cases, we think it may have required, and it was slow, and the solution to why it was so slow was to get bigger hardware and more memory, which would have made it bigger than the data warehouse server. The cost of a tool is not just the tool, it's the cost of the hardware you need to run it, the cost of training, because if you don't train your people in the tool, they'll never use it. It will become shelfware. And I actually wonder how many of these tools are sitting out there really as shelfware instead of being used. So I'm a big fan of doing things in scripts. And I was really cynical when Informix came out with the data warehouse feature of this is just another tool. The thing I like about it, though, is it allowed me, it was a tool, yes, but it allowed me to pull in my existing scripts and not have to reuse them. And it's turned out to be very flexible in allowing you to use a high-performance loader and call a script that then loads data using the high-performance loader. So let's take a look at the Informix Warehouse feature. This is a new offering. It's targeted for Informix customers that have data warehouse requirements. It's a client-server architecture. It does your ETL, ELT, in a GUI environment. And there are 4 components to it. One is you have to have Informix. 2 is there's a design studio where you build your ETL process, and that runs on Windows or Red Hat, Linux, any one of the Linuxes, SUSE also. Then there's the SQL warehouse tool, which is actually what I call the production running piece. So you use the design studio to build your load process, and then the SQL warehouse tool is where you actually run it. And then there's an admin console, which is for your schedulers who can use it to monitor and to schedule loads and things like that. So let's dive into it a little bit. First of all, it's built on Informix 11, and it takes advantage of all the features of Informix 11. I've got a whole bunch listed here on the slide. The Design Studio is Eclipse-based, so it runs on your desktop. And the idea is you create a project, that's a load project. It allows you to see your tables, see your data, see your steps as you go through in a graphical environment. And it's great for showing your boss. This is how the data warehouse gets loaded. Shell scripts, bosses tend to have a hard time with, but this is a really great way to show them. These are all the steps in the data warehouse load, and they don't have to see the shell scripts. They see this nice GUI document of flow controls. And so it looks something like this. You have your database connections, you have your different data warehouse perspectives, and you basically drag and drop and build your flow. And there's a whole bunch of operators on the right side that allow you to do things. And you notice one operator there is custom SQL. There's also another operator called command, which allows you to run a shell script or a Perl script or any other kind of script you want. And I use those very heavily in this process. The key point I want to make here is it also allows you, if you've built a warehouse with a bunch of scripts, to take those scripts and integrate them fairly easily into the Data Warehouse Studio, because all you have to do is say, okay, that script I have written here goes here, and the script I have written here goes here. And you have a nice graphic with all your scripts tied together. Now, the SQL Warehouse tool works with the Design Studio, and that's where the ETL work gets done. And this is where you do things like, say, this table is input to this, and you join it with this, and group by this, and then this is the target. And again, you have the option of using custom SQL and commands here along the way. Now, the idea is you get a project. The project is your ETL process. So if you had 10 data marts, you might have 10 projects here. And each project then becomes something that you can load separately. You can also do your physical data modeling in this tool. It's great for building your load and building your data warehouse. If you're starting from scratch, this is probably a very easy tool to use to start from scratch and build a data warehouse from. And you can see your data models within the tool. Here's an example of a bank customer data model within the tool. And you can see your data flows of what goes where to get the data into the target table. And the last thing is this also handles things like emails to users. This can handle things like generating the email that gets sent out to users at the end. It can handle triggering your business intelligence reports at the very end. So you can embed almost anything you do in a shell script you can do in this tool. Everything gets put together into a zip file, which becomes the package that you then take to the admin console, and that's where it gets scheduled and run. Scheduling is really important. When you have 10 or 12 data marts in a data warehouse environment, and next month I'm going to talk about what I call the enterprise view of a data warehouse, which is when you have 10 or 12 data marts. But scheduling is important because you don't want to schedule them all to run at the same time. You want to have a staggered load schedule so that they're not conflicting with resources. They're not conflicting with disk I/O. They're not conflicting with users. And so this allows you to do scheduling and set up when things run and see the results of what's run. So in summary, this is probably the best tool out there that I've seen to, and this is from a skeptic who doesn't like tools, okay, to use to build an Informix warehouse. because it does provide you with the graphical kind of interface, but if you know SQL and you know scripting, you can build almost anything you want within this tool. Now, that's the end of this presentation. Next month, I'm going to talk about the enterprise data warehouse. And this is the question of, I've got 10, 12 data marts. How do I turn that into an enterprise data warehouse? Or also, if you're just starting out with one data mart, how do you plan so that one data mart is ready for your enterprise? The way I like to think about this is you've got to start with one data mart. You can't start from the top down. You can't start with the enterprise. But when you start with that one data mart, you need to have the enterprise vision in mind and know what you want to do. You want to know the big picture, so you want to know how that data mart fits into the enterprise. And that's what we'll talk about next month. Well, on behalf of Advanced Data Tools, I'm going to open it up for questions in just a minute. I'd like to say thank you all for attending. We have a great team that we've spent many years together building very fast data warehouses. And this is from the Informix User Conference last year, a picture of all our staff there. I want to highlight that at the end of April. Is probably going to be the best Informix conference you can ever get to. And there are discounts for IIUG members. There are tutorials. This is a phenomenal experience, and I know I'm going to be there, and we'll be showing some of our data warehouse things. We'll also have another fastest DBA contest there. There is a tutorial on the Informix warehouse feature that I would highly recommend anybody who's interested and wants a hands-on tutorial to go to this conference. This is the best way to learn and evaluate it, is to try it out yourself. And this conference is one of the best environments to do that in. Now, I'm going to unmute the lines and just see if there are any questions. So bear with me for a minute. You can also, if you have the chat window open, you can ask me a question by chat. So are there any questions out there? I'm going to say going. Any questions? Well, if you do have questions, feel free to email me, and I'll be happy to answer them as best as we can. My email is lester@advanceddatatools.com, and I thank you all once again for attending the webcast, and look forward to seeing you there. I just got a question from someone, and the question is, what is a fact table? This was in the chat session. And what I would suggest, if you want to get more information about fact tables, take a look at the replay from my last webcast. That's available on our website, same place where you registered for this data warehouse. In the last webcast, I talked about a fact table and a dimension table and how you build those. But the short answer is a fact table is the table that has the numbers in the data warehouse. And the next question is, what is a dimension table? Dimension table is where you have the lookup information in a star schema. And actually, again, I'll follow up with you offline on this, and I think take a look at the last webcast I did and take a look at the replay. I'm hoping that will help you there. Any other questions? Okay, well, if that's it then, thank you all for attending, and we look forward to seeing you on the call next month.